Hi, everyone. So today I just want to take you through a quick note sheet that'll have us solve 4 different equations, and we're going to see a couple things happen through these equations, and we just want to use this note sheet to just kind of remind us a few common things that happens as we solve for x or for other variables in these equations. And we just want to remind you that solving equations in algebra have a big component of every single lesson, and especially every single assessment this trimester during this course. And so the stronger that our abilities are regarding these things, the better off we'll be. And so let's start this trimester off strong. Let's review solving equations. Let's talk it through now, and you will have an opportunity to practice this together with the rest of your teammates a little bit later on today. So let's start with example 1. So first thing I'm going to do is, you don't always have to do this, but I'm going to find the equals sign, and I'm going to draw a line down it. That way I can really see, hey, we have 2 sides of this equal sign. We have a left side, which is underlined in blue, and we have a right side, which is now underlined in blue. Left side has a whole bunch of stuff. You can see x's, you can see regular numbers, pluses, minuses. On the right side, you just see a -3. So the first thing we want to do is combine like terms. And so we can combine anything that have x's, we can put those together, and then anything that is just standalone numbers, we can put those together, but we need to do it separately. So let's look at our x's. We have 2 x's and 5 x's. That is going to be 7 total x's, so I can combine that into 7x. And then I'm going to look at my single numbers. I've got -4 and -13. If I have 2 negative numbers, when I put them together, they're a little bit more negative, and so that's going to be -17. All right, and now I've combined everything on the left side. My 2 blue underlines, those are x's, they combine to 7x. My 2 red underlines, those are just 2 standalone numbers. We can put those together to become -17. And so then that'll equal the other side, and for now, still just -3 on the other side. Now what we want to do is, to solve this equation, we got to get x by itself. In order to get x by itself, we want to make sure we look at everything around this equation, and we want to get, the thing that has x attached to it by itself first, everything else to the other side of the equal sign, and then we can get that x all by itself after that. We get everything from one side of the equal sign to the other side by doing the opposite. And so if you take a look over on this side of the equation, we have 7x and we have -17. Again, we need to get this x by itself, right? So let's get rid of this -17. Again, we'll do that by doing the opposite, and we need to do it to both sides. So I'm going to plus 17 to both sides. That's going to take the -17 away from the left side and move its value to the right side, since we're doing it to both. And so now I just have 7x on the left side, and that's going to equal whatever -3 plus 17 is, which is 14. So now I have 7x all by itself, and I just want x. Now 7x is 7 times x, so once again we should do the opposite to both sides. The opposite of timesing by 7 would be divide both sides by 7. And so when we divide both sides by 7, these 2 7s cancel, giving us just x by itself, and 14 divided by 7 is 2. So in this example, x equals 2. All right, now that's the same thing basically we want to do for all the other examples, but they're just going to be slightly different. So let's move on to example 2. I'm going to find my equals sign. I'm going to draw a line through it so that my left and right side is very clear. And then I'm going to start doing what we call combined like terms. I want to find my things with x's. Here's a 2x and a 5x. And then all my things with just regular numbers. And we want to put those together separately. Now, notice on this side, there are 2 regular numbers, a -13 and a -3. So let's put those together right away. So on the left, we still have our 2x minus 4. We're not touching that yet. We're not touching our 5x yet either, so we still have that. But let's put -13 and -3 together. That will give us -16. All right, now I have like terms. I have x things and then just number things on both sides of the equal sign now. So now I just need to move them back and forth. And we didn't move x's back and forth in the first example, but we did move some regular numbers back and forth, like when we added 17 to both sides. So we're going to do the same idea with the x things. We have a positive 2x and a positive 5x. So to move those across, we want to add or subtract. We want to do whatever the opposite is. So in this case, if we subtract 2x from both sides, we can take that 2x off of the left and move it to the right. That will leave us with -4 only on the left now. And then 5x minus 2x is 3x, and then we have a minus 16. And then remember, we want to get x by itself. So here's our 3x. Let's get that by itself. So let's do the opposite of minus 16 to both sides. So we'll add 16 to both sides. And negative 4 plus 16 is 12, and that's going to equal 3x. And now we've got 3x all by itself, so the opposite of 3x would be, let's divide by 3, and these 3's will cancel. And 12 divided by 3 is 4, and then that's what x equals. So x equals 4. All right, moving down to number 3. Here's the first one we've seen today with parentheses. So if you take a look, the 3x minus 5 is in parentheses, and we have a 2 directly on the outside of that. But there's no plus or minus between the 2 and the parentheses. That 2 is just kind of like stuck on the outside. When this happens, we want to think of what we call distribution. We can take the 2 that's on the outside of the parentheses, and we can multiply its value to every single thing inside the parentheses. Inside this parentheses is 2 different things, 3x and negative 5. So if we multiply both those things by 2, we can get rid of that 2 that's out front, and we can get rid of the parentheses because its value would have been put inside. And so let's do that. Now, once again, we'll find our equal sign and we'll give ourselves, the nice left and the right. And so now let's go back to our distribution. We need to do a 2 times 3x. 2 times 3x is 6x. And then 2 times minus 5. 2 times minus 5 is minus 10. And then that's going to equal 8. And now everything else from this problem is just like what we've done up top. So let's figure out, we want to get x by itself. We have a 6x, we have a minus 10. Let's do the opposite of minus 10 by adding 10 to both sides. And that'll take this away. And that'll give us 6x equals 8 plus 10, which is 18. And then we'll just divide both sides by 6. And that'll give us x on the left. And then 18 divided by 6 is 3. All right, cool. So one more problem. Looks like it's another distribution problem. Make sure you are careful about your symbols. This is a negative 5 on the outside. We want to distribute the entire negative 5. So make sure we see that minus sign there. So we'll do that in a second. Let's split our equal sign. And right now we got to do negative 5 times everything in parentheses, just like what we did above. And so negative 5 times x is negative 5x, and negative 5 times negative 3 is positive 15. So we'll flip that to plus 15 because the 2 negatives cancel. And then we have a 15 minus 5x here as well. So let's combine our x's. I have negative 5x here and a minus 5x on this side. So on the left side, if I just add 5x to both sides, right, we can take that value off the left and we can bring it to the right. But the problem is when I add 5x to both sides, that cancels the 5x off the left. Negative 5x plus 5x, that goes away. But look at what's happening on the right side as well. A minus 5x plus a 5x again. Well, minus 5 plus 5, that's 0. That's what happens when things cancel out. Both of those go away. And it just leaves us with 15 equals 15. Now, there are no more x's. So there's nothing else we can do to get x by itself. So how do we interpret this result? What does it mean when it says 15 equals 15? Well, if you take a look real quick, and I'm going to clear some of this back up again. So if you take a look at these things again, and if you look at this statement right here, we have a minus 5x and a plus 15, and a minus 5x and a positive 15. The left side of this equation and the right side of this equation are exactly the same. Anytime you have a situation that's exactly the same, and you see it real nice when the x's go away and you just see one number equals the same number, like down here by the arrow, anytime that is occurring, that is the key for you to know that the answer is like any number, or all numbers, or all numbers are solutions. Again, since the left side of the equal sign and the right side of the equal sign are exactly the same thing, no matter what goes in for x, no matter what x equals, the left side and the right side will stay the same. Anytime that happens, it doesn't matter your numbers. Any number is a solution. Left and right are always the same, and so all numbers are solutions. And again, one thing that keys us off to knowing that is, hey, we get a 15 equals a 15, or any number equals the same thing. Well, that's definitely a true statement, and so the left had to be equal to the right, so all numbers are solutions. All right, so those are some good notes about solving equations. A lot of combining like terms, a lot of distribution, and then a kind of a tricky interpretation one at the end. And so please keep this sheet and use it as you and your group work through some more examples later on in the class period. If you have any questions, if they come up, towards the end of the day today, make sure you jot those down and come with them tomorrow. I can help anybody out. But I hope you have a great rest of your day. Thank you for listening. Have a great day. Bye.